All right, guys, so we're going to solve exponential equations. So you can see by this one right here, number one, we are trying to solve for x like when we typically solve any other equation. So what do we need to do is get rid of everything that we can that is with the x until we can isolate it. Well, this right here is a multiplication 3 times 2 raised to the x. So what I can do is I can divide both sides by 3. So that would give me 2 to the x is equal to 14. So now what I have here is this base of 2 obviously being raised to the x. So I'm thinking, well, how can I isolate that x? Well, if you recall, exponentials and logs are inverses of each other. So if I want to get rid of this base of 2, what I can do is do log base 2 to both sides. So by doing that, what happens, this, which is log the base 2 of the 2, that goes away. They undo each other because they're inverses. And that gives me x is equal to log base 2 of 14. And if you were required to do an approximation of that, you would just key this value in or look it up in a table, which I don't think they do that anymore. Pretty much just use calculators, and you would get 3.81 as your answer. All right, let's look at the second problem here. So now we have that natural base e. And again, we are trying to solve for positive x. So we're going to do everything we can to isolate that. Well, the first thing I can do, hopefully you can see, I can add the 4 here to both sides. So that would give me negative 3e to negative x is equal to negative 9. And then, of course, this is a multiplication. So I can divide both sides by negative 3, and that would give me e to the negative x is equal to 3. So now going back to like problem number 1, we're thinking, well, how can I get rid of this base of e? And again, it's going to be a log because it's the inverse, but if you have the natural base, the inverse would be the natural log. So we're going to go ahead and do ln to both sides. And what happens is this goes away, they undo each other. So you get negative x is equal to ln of 3. Now, of course, we want to solve for positive x, so we just divide by negative 1. And we would get x is equal to negative ln of 3. And if you needed to approximate that, that's roughly negative 1.1. All right, let's look at this problem here. Now, hopefully when you see this, something should come to mind. Basically factoring, like a quadratic. Because see, here you have the x's in 2 different terms. So what I'm going to do is a substitution. Now, it's not necessary. You can go ahead and look to factor this from here if you want, but sometimes it's easier to do a substitution. I'm going to say let x equal, let me fix that, I don't like the way that looks. Let x equal e to x. So if I do that, then this expression here becomes x squared minus 3x plus 2 is equal to 0. Well, now this is a lot easier to factor. You're familiar with this. So I'm going to go ahead and factor that and get x minus 2 times x minus 1 is equal to 0. Then I'm just going to go ahead and put back that substitution. So then this would give me e to the x minus 2 times e to the x minus 1 is equal to 0. So all I did was substitute back in the x for e to the x. Well, how do you solve when you factor? You set each factor equal to 0, so e to the x minus 2 is equal to 0. e to the x minus 1 is equal to 0. So we're going to go ahead and add 2. So I get e to the x is equal to 2. I'm going to add 1, and e to the x is equal to 1. Well, of course, that's not the solution. We're trying to solve for x. So we have the natural base, so we're going to do ln to both sides, and then do ln here. So of course, that gives me x is equal to ln of 2, and x is equal to, and of course I did not put the ln here, sorry about that, ln of 1 is equal to ln of 1. And if you were to evaluate this, if you're going to approximate, and then this of course is 0. So we have these two solutions for number 3. And if you plug them in, you would see that it works. All right, so this last problem here, this one is a little tricky. You can see you have 2 different bases. So I got 5 and then a base of 2. I've got 2 different bases here. So what can we do? Well, the way that I'm going to handle this, I'm going to put one of these over to the other side. So I'm going to go ahead and add 2x to both sides. So I get 5 to x minus 1 is equal to 2 to the x. So now this is where you have a choice. I could just do, because again, if I'm trying to get the x, I got to get rid of these bases. Well, I can't get rid of both at the same time because they're different bases. So I could choose to do log base 5 of both sides, and proceed from there. Or I can just choose, let's just say generic, like log base 10 to both sides, which would not get rid of any of these exponents, but I could isolate it. So again, it really depends on how you see this problem. So what I'm going to do is I'm going to go ahead and do log base 5 to both sides. So now what's going to happen here? So this is going to go, because I'm doing the inverse, and I get x minus 1 is equal to log base 5 of 2 to the x. Now, if you remember from the properties of logarithms, I can drop this down to the front. So that would give me x minus 1 is equal to x log base 5 of 2. So how does that help me, and where do I go from here? Again, I am trying to isolate. I'm trying to isolate this x term. That's what I really want to do. I need to isolate that. Well, if I could get them on the same side, I have a better chance of that. So what I'm going to do is I'm going to add 1 to both sides. If I can write the 1 instead of a plus twice. And that's going to give me x is equal to x log base 5 of 2 plus 1. And then I am going to subtract this right here to the other side. So that is going to put all of my x's on one side of the equation. So I will have x minus x log base 5 2 is equal to 1. So now you're saying, well, how does that help me? I'm still no closer to solving this. Well, think about factoring and a common factor. I can go ahead and factor out this x and say this is x times 1 minus log base 5 of 2, which is equal to 1. Now I have this x isolated in a sense by just doing a division. I can have it completely by itself. So if I divide both sides by 1 minus log base 5 of 2, I have my answer, which is x is equal to 1 over 1 minus log base 5 of 2, which we will approximate, and you would get 1.76. All right, so hopefully this helps you with solving your exponential equations. And in the next video, we're going to do solving the equations that contain logarithms. We'll do that on the next video.